Welcome to the talk on automation alchemy on a mass scale, turning costly manual tests into automation gold. Sara and I are really excited to be here and talk about our test automation experience and share many of the things that we learned. Please feel free to interrupt us at any time and ask questions. We've tried to highlight what we thought were the main areas that we wanted to focus on, but certainly all questions can lead us into different directions, and we are open to that. And at the end, there is some time for Q&A. So, what are your takeaways, or what are the takeaways from this talk that you'll get? Are you starting to work on automation and need a quick rundown from someone who has done it all and can give you a 20/20 view of it? Or are you a team or an individual which has already started their automation efforts but doesn't know what challenges lie ahead? For either one of these or any other combination, please stay to watch this presentation to get some insight. We worked on this for years. We automated thousands of hours of manual tests. We learned some great lessons along the way. In this talk, we hope to give you a glimpse of what we learned, ideas on how to make your test automation framework more flexible and maintainable, inspiration for handling automation with scale, plus some ideas of what it takes to get there, and maybe a lesson or two. We will consider this presentation a success if you can take one idea from this back and implement it in your own framework. And one thing I can promise you, if you stick around for this talk, you will get some free beer after this. So a little bit about myself. My name is Priyanka Gupta, and I'm the engineering director at Blackboard. I was born in India and moved to the US to do my master's, and I live in the DC area with a nice family. I have 2 girls, as you can see, and a husband. I love working in the technology field, and I have been doing that for more than 15 years. I'm an engineer at heart, and I have done played different roles, developer, test engineer, product owner, the whole gamut. I had managed the test automation at my company for our enterprise application, and this presentation is about our experience doing that. There was never a dull moment.
Hi, I'm Sara Eisen. I'm a Maryland native. I was born and raised there, and I live and work in the DC metro area. I'm the mother of 2 in a family of 4 plus 1 dog, and I've been doing work related to automated testing for the past 15 years. I graduated in 2000 with a Bachelor's of Arts degree in math with an emphasis on computer science, and right out of college, my first job was writing and maintaining automated tests using a terminal server blood banking software, using the latest technology at the time, which was Windrunner. After a few years of doing that, I moved on to Blackboard, which is a major educational technology company that had recently gone public, and I stayed there for 10 years. My role at Blackboard grew as automated testing in the organization went from a very small battery of smoke tests into a much larger test automation framework that supported thousands of hours of testing. Eventually, I left Blackboard and went on to take on other QA engineering roles, and currently I'm a senior QA engineer at Optoro, which is a reverse logistics company, and I started there in June.
So let's start by talking about our journey. As test and development teams increasingly depend on automated testing as a crucial part of the development lifecycle, they also must contend with what is the end result. More tests to manage and more test results to interpret. New best practices are needed to manage all these test tools, interpret the results, and to ensure testing is a seamless part of the development lifecycle. One such experience is ours, and we hope we will help you with our story. Like all stories, we'll go through the beginning, middle, and end. We'll start with a sneak peek into the history of test automation at our company. We will then go into some details of the implementation and challenges that we faced as we grew in scale. Finally, we'll cover some best practices and go over the lessons learned. So this picture pretty much sums it. The various stages of automation at Blackboard and how we evolved over time. This presentation will actually just cover the fitness magnet stage, which is the last one. But the evolution itself will resonate with many of you here. So the first one is what we call the bad habilis stage, which stands for the bad testing. And this was the build automated test. And this was nothing but having a bunch of silk tests running on one server, plugged into, having one single monitor there, and you run your tests, you stand there, you watch them, and you see how they're performing. We were very much a manual shop at that time. And that was like 2004 to 7. And then from around 8 to 10, we went into what we call the IVPS erector stage. IVP stands for Internal Verification Plan, these were automated CRUD operations with some very basic functionality, testing some very basic functionality, and the tests were written in Java using Selenium WebDriver. At this point, we had engineers also starting to write JUnit tests, so we had some amount of automation, teeny tiny bit, but we still had a long way to go. Finally, 2011 onwards, we came into what we call the fitness magnet stage, where we really focused on test automation and made it a priority. This presentation will cover this period, and where we really walked, ran, and stumbled, doing all of it in an automated way. So where did it all start? Well, everyone wanted to do more automation, but it all started with a management mandate, at least for us. We need more test automation. We were mostly a manual shop, as I pointed out before, till this point, and then we had to move towards test automation. So the mandate given to us was convert 5,000 existing manual tests to automated, reduce the test cycle time, which at that point was 3 weeks, down by 80%, so bring it down to 2 to 3 days. And along the way, support multiple browser and OS combination and all of that. Needless to say, this was easier said than done. We faced many challenges, including the fact that our team of testers was largely non-technical, and we did not have the bandwidth to hire new staff, as it's mostly the case with everyone. We were also supposed to automate new feature work. So pretty much like, building a plane while flying it.
So what did we do to meet this challenge? Well, we built a Selenium wrapper. Sure, there were a lot of Selenium wrappers out there at the time, but for us, it really made sense to write our own. So why did we bother to write our own? What made ours unique? Well, we used the fitness wiki tool on the front end of our wrapper so that the non-technical people working on our team could easily write Selenium-powered tests using plain English and wiki table format. We baked into our frameworks concepts of not repeating ourselves by using discoverable, reusable scenarios that could be defined on the wiki layer. And we also had single points of truth for GUI object definitions, which we called components, and those were also defined on the wiki layer. We had been doing test automation at Blackboard for several years prior to writing this framework, so we incorporated a lot of what we had learned into the framework. Things like special fixtures for verifying and interacting with custom application widgets were built into our framework. For example, our application had a lot of tables with dynamic user-generated data that had crazy XPaths, and we wrote fixtures that could figure out the locators of the cells of the tables based on the column name and contents that could be passed in through the wiki. In the next few slides, I'll delve even deeper into how the front end of our framework was consumed. This is what a test page looked like in edit view. You could also render it through the browser into nicely formatted tables. And here you can see examples of components being referenced, scenarios being called, and the Selenium API being invoked. This is a zoomed in view of that same test. You can see in the fourth line of step 2 that the click method is being called. So here the Selenium method for clicking is called on a predefined component page called page course.link content. A side note here is that we had standardized component naming conventions, which the entire team followed. So, for example, links were all called something like page with the page name dot link with the link name. This made finding and keeping track of things easier. The last line of step 1 is calling a login scenario, and it's passing in a data pool. I'll get more into those in a couple slides. And the third line of step 2 is calling another scenario to get into a course. You can also see other fixtures and scenarios being called here to do verification and logging. This slide shows how we were able to define GUI components on the wiki layer of our automation. Instead of putting component definitions like XPath and HTML ID directly into our infrastructure, we allowed the consumers of our framework to define their own components in the wiki. So here we can see 2 components being defined by their HTML ID. Components also allowed for XPath, and we could parameterize the XPath component definitions. This shows how we could parameterize those component definitions. In the first table, there's 5 separate component definitions, which all have almost the same XPath, but the text is different because that's generated by the user of the application. So the second table shows the same exact component being defined by a single component definition with an XPath that takes in a parameter. And the third table shows that definition being used in a test with the component being passed into it, with a parameter being passed into it. And we could use the same method to pass even multiple parameters into a component definition. Another part of our framework that we developed was for rapid data setup and teardown. We felt really strongly that if we visited a page through the GUI one time through the browser, it was not necessary to go back to that same page to do data setup or teardown during a test. So instead, we developed a tool to get this done through the API. We worked with the developers on that. So we could make API calls through our framework in the wiki tables using English keywords. And our setup and teardown was done in a flash. So data pools. The application we were testing had some pretty complex data structures. Many objects had more than 5 fields that sometimes needed data in a test. And to make passing this data around and manipulating it easier, we introduced the concept of data pools. Data pools were basically fixtures represented by tables of data written in separate flat files that could be referenced by a test and passed into scenarios. And they provided a single point of truth for the data being used in a test, which is easier than passing disparate pieces of data that may be repeated throughout a test. And they made it less likely to break things when we had to change the test data. One more aspect of the tool that we developed over time was the ability to support different versions of plugins deployed in our test environment. So a big challenge we had was that our monolithic legacy application was being ripped apart into several smaller applications, and each of those smaller applications was versioned, and we had to support different versions of each. Any given test would need to be compatible with several different versions of each plugin. For example, if I had version 1 of the gradebook and version 2 of the gradebook, and each version had its own workflows and component definitions, our test would need to support both. So the solution we came up with was to dynamically load the version scenarios and components based on the versions of the plugin in our test environment. So as long as component keys and scenario names didn't change from one version to the next, only the definitions did, our test didn't need to be updated to support the different versions, only the definitions of the scenarios and the components. So dynamic loading of version components and scenarios allowed us to have different GUI mappings and application workflows plug and play really nicely with each other. So we developed a really great framework to meet the challenge of automating a large volume of manual tests, and then
And then we ran into the problem with scale. We were writing tests at an alarming rate. Soon the biggest problem we had was with scale. We were automating every test case that was being outlined for a new feature, and additionally had already automated all our older manual tests. 18,000 UI tests had to be run on each single code line, with testing on 3 code lines every single day. These tests were not small. In fact, some were the size of many tests put together, so they ran really long. So what did we do? One common answer to having many tests is run them in parallel. So the first thing we created was our own solution to executing tests in parallel and reporting the results of these executions. We did look at some of the solutions which are out there, Selenium, Grid, and Jenkins and others, but at that time, it did not provide us with the features and capabilities that we needed. Some of the features provided by our next-gen parallel executor were, it used test slaves to slice up large test suites into multiple parallel run parts. We used 100 or so slave machine to run a single code line. These tests ran almost for like 20 hours or so per day. It identified tests which had above average durations that require special attention. It automated rerun of failing tests. We all know how flaky UI tests can be, and you really do want that. It had the ability to run destructive tests on a separate slave machine allotted to it. It had ability to tag tests, so like providing them with different labels, so you could easily search through them and group them based on different criteria. Also, this was all a web application, so it has an easy UI interface. And lastly, anytime you needed a new feature, you could easily build it. This is a screenshot of the UI of our test executor. A couple of things which pop up when you look at it. You can see the live feed on it where it shows the tests which are being run and what state they are in, the ones which are being executed. And in this picture, it doesn't really show. It just shows the ones which have finished, passed, or failed. But it was a live feed, so you could really see what was going on. You could determine which server was being run against, on what slave machine they were being run. You could look by execution time periods or any such combination. There was this whole search bar where you could search for different things by different criteria. And also it had quick results. We had summary available, and you could get summaries of last 5 days, 1 day, 10 hours, 5 hours, anything. So the next thing was reporting. Well, if anyone you have dealt with management, you know their fascination for reports in all forms and sizes with every possible combination. We had such requirements too, along with the fact that we wanted to also get a deeper look at how our tests were changing day to day and month to month. So we developed a rich and dynamic reporting capability with which we could generate dynamic reports with different criteria and fields. We also had heat maps for our results, which could be viewed for like past week or month. So this is actually a view of the heat maps showing how the tests have been performing over the period of time on which it has been taken. So the next issue with scale was dealing with the logs that were generated from our failing tests. Looking at these logs, it was difficult to sometimes figure out what the actual problem was. We had 20 hours of execution happening on so many machines, so we just had this humongous logs to handle. So for that, we implemented centralizing our logs using Logstash and Kibana as the interface. Doing this really gave us a much better perspective of our failures. We could find patterns in our failures. For example, we discovered that after running a specific test, a whole bunch of failures would occur. And it turned out to be a destructive test. And an example of a destructive test is a test which changes the system time of your machine. So if that sort of test runs, then consecutively, the later tests which are using time will probably start failing. Another discovery we made was with a particular scenario. We found that it was making an asynchronous call to our application, and that would sometimes fail. This scenario was being called by multiple tests at the same time, and it would cause the application server to just fail. Through this discovery, we found a bug in our application, but merely looking at the logs, it would have been really difficult for us to pinpoint that that was the problem in our application. But putting it all together and then viewing it through this mechanism really helped us figure that out. Also, some environmental failures were found after log centralization. Since now the otherwise random failures had a common source which could be tracked by the different filterings which was available on the Kibana interface. An overview of our automation will not be complete without telling how we were set up as teams, and I think that really helped us go where we were because of the way we were structured. I look at it as we were actually 3 sub-teams within our group, and I look at it as like the 3 sides of a triangle. One side built the framework for the automation, developed best practices, provided tooling, and was responsible for solving all the technical problems. Another side wrote the tests based on these best practices and frameworks built by the previous group. And the last side was the one that was executing the tests, keeping the environments clean, and doing all other maintenance activities. So the 3 groups together really worked very well, and we were able to achieve what we did.
Switching gears a little bit here, now that we've summarized the framework and tools that we developed for automation at scale, I'm going to talk a little bit about some of the processes that we had to follow to support this. So working with a remote team of people with varying technical skills and abilities was very challenging at times. To ensure consistency and maintainability of our tests, we had to regularly review the tests and find the places where things were problematic and create best practices around them. We had a 1-hour-long best practice meeting every week where everyone involved with the test automation effort would be in attendance and encouraged to participate. Anyone could suggest or head up a best practice or provide feedback about what was or wasn't going well with our automation. And all of our best practices were documented on the wiki, which everyone had access to. This is a picture of an astronaut taking a shower. So why is this relevant? Well, one of the most important best practices that we found that we had to follow was related to data hygiene. Tests really needed to clean up after themselves, or else they would cause failures in subsequent tests or failures in other tests that were going on at the same time. For example, if a test downloaded a file, we had to make sure that file was put into some predictable location that we could periodically clean out. And any test that changed server settings or restarted services or something had to be quarantined, as Priyanka mentioned earlier, into a disruptive test set so that other tests weren't running against the same machine. And we also use unique test key prefixes for any primary key type of data to avoid collision with other tests. A couple of other best practices that we developed along the way were related to localization and data file setup. Our application was localized, which meant that static text within the application was mapped to a localization key and defined in a resource bundle. So instead of directly hard-coding any text into our tests, we referenced the localization key, and our automation framework loaded the bundles and could map the key to the localized text. This made our tests much more agile because, of course, the text is always changing, but the keys themselves change much less frequently, so our tests only broke if the keys changed. We also had best practices for data file setup. Getting the test data onto each virtual machine and system under test was a non-trivial task. It had to happen at the right time every day, so we had special tools developed to help us do this.
Finally, what did we learn? And more importantly, what can you learn from this story? The number one thing that we can say now is, maintenance is the number one reason that kills QA automation. Once our automation was in full swing, maintaining it became harder than the task of getting it to where it was. Thus, ask yourself this question every single day. Does this piece need to be automated? So thinking of the what is more important than the how. Concentrate on the what. Some of the examples of the how are like which tools you're using, what type of testing framework, is it BDD or something else, mobile, do you have to think about mobile, or does it tie in with continuous delivery? But the what, the question what is, some of the examples for what are, is it a piece of code too complex to automate and the value of it too little? Is the product not stable and changing too much? Can it easily be done manually? Both these questions are important, but let's not go through the motions of automating everything that comes to us. Anything that failed consistently should not run until it's fixed. A flaky test is worse than no test. This may seem the most obvious lesson, but it's one of those which does not get followed. UI tests are very flaky by nature, we all know that. And when you have too many of them, it sometimes gets tiresome to fix them or take them out of execution, pull them, put them back in, etc. So create easy automated ways to trigger fixing of failing tests, like generation of a critical ticket when a test fails in your bug tracking system, getting it informed to the developer or the test engineer, whatever is the most convenient way to do it, but go ahead and do that. Find ways to simplify the process of weeding out flakiness. Don't get lazy on this. Is it a cube, is it a cone, or a pyramid? Let's stick to the testing pyramid. Yes, I'm talking of the testing pyramid again. We have all read and heard about it, and many of us follow it. But with our experience, we can tell you one thing. Sometimes it takes time to take a back seat and really see where your testing is heading, to really visualize where in the spectrum you fall. Try to stay true to the testing pyramid, since it quickly adds up on cost if you're doing it the other way. Take a step back occasionally. Once you have a solid framework and some set practices, make sure you take a look at where you are headed with your testing. And there are many, many more lessons. Continuously test and integrate code, automate environment provisioning. It is essential to have as much automated provisioning as possible in your data, in your environment setup. Spending some time for it will give you a lot more in return. And trust me, we saw that happening with us. Deliver in small increments of functionality, employ loosely architecture coupling within and between applications, and much, much more. Finally, have fun doing it. We had a great experience, and with all the mistakes and progress that we made, it's a great sense of accomplishment for us. Test automation can be very challenging, but enjoy while you do it. Thank you.